All right, so we're back here for part 2, and now we're going to look at the equation of a line. Now you're familiar with y equals mx plus b. M is the slope. That is the number that's multiplying the x. B is the y-intercept. That's where we cross the y-axis. Okay, so a little review there for you. And let's see, directions. Let's go to the bottom. Graph the given equation and the line that is A, parallel, and B, perpendicular to the given line through the point. Okay, so there's a lot going on there. So let's take number 10, y equals 1/3 x plus 1 through 0, 3. Let's do this first. Let's go ahead and graph this line. Now the y-intercept is positive 1. That's the b value. So I'm going to go here, 0, 1, and I'm going to put a point. That's the y-intercept, where we cross the y-axis. The slope is 1/3, so that means the rate of change is up 1, right 3. From here, I'm going to rise 1, run 3, both positive. And now that I have 2 points, I can draw my line. Now if I want to put a few more points on there just to be accurate or use a ruler, here's the line y equals 1/3 x plus 1. Now what they want us to do though is they want us to draw a line parallel to this that goes through 0, 3. So let's plot 0, 3 here. Now you may be able to eyeball this, but if we think about it, if the slope is 1/3, then that means that the parallel line slope is equal. It's the same, it's 1/3. So since I know it's going to go through this point, I just need to rise 1/3, and now I graph it, and now we have parallel lines. Okay, so for part A, where we graph the line parallel to this one that goes through 0, 3, I'm just going to put an A there. That was part A. And you can look at it, it looks parallel. So all I have to do is count the same slope. Now perpendicular is the opposite reciprocal. So I'm going to flip 1/3, and since this was positive, it becomes negative. So now my slope is -3/1. Again, we're going to go through the point 0, 3. So from here, I'm going to count down 1, 2, 3 over 1. When I see that this is negative, I always think of the negative as being in the top of the fraction. So it's not negative, negative. That would make it a positive slope. It's down 3, and then positive 1 is right. So it's these 2 points. Let me draw that. Actually, that looks pretty good. That's my answer for B. And what we have now, here's parallel lines, these two, and then the green one is perpendicular to y equals 1/3 x plus 1. Now we don't need the equations of these, it doesn't ask for them. So we're done. So let's take 11 here, same thing. We're going to start with y equals -3/2 x plus 2. 2 is the y-intercept. I'm going to plot 0, 2. The slope is -3/2. So from here, that's a negative slope. We go down 3, right 2. Now again, I can do this again to be more accurate. I can go down 3, right 2. I could also go up 3 and left 2. Think about this. If the slope is down 3/2, that's the same as up 3 and left 2. These are both negative slopes. So normally I go up or down. I always go to the right at the end, but if I wanted to, I could also go this way and all the points are still on the line. So here's the equation of the line. We graphed it. Now we want to draw a line, part A is parallel to this, through -1, -2. So -1, -2, we're going to plot that. That's x comma y. So if the slope's -3/2, parallel slope is the same. It's equal. So I'm going to count from here, down 3, right 2. And you can see if I draw this, it certainly looks parallel. That looks good. All I need is 2 points on the line to graph. Now for perpendicular, we know the perpendicular slope is the opposite reciprocal, so that's 2/3, and negative will become a positive slope. So 2/3. Again, from this point, now we're going to rise 2, run 3. Now I have 2 points. I can draw my line. That's part B, and this was part A. And this will be perpendicular. So that makes a 90-degree angle. Okay? So the key is understanding parallel lines have the same slope. Perpendicular is opposite reciprocal. So we're going to flip to the last page here, and we're going to do some equations. Write an equation for a line parallel to y equals negative 2x plus 11 that goes through the point negative 3, 5. So now we actually want the equation. Here's the first line, and we want a line parallel to that. Now, right here, the slope is negative 2. Parallel lines means same slope. So parallel line will also have a slope of negative 2. I can think of that as negative 2/1. They tell us 1 point that we go through. So we go through negative 3, 5. Now I'm going to show you 2 ways to do this. If we do the old y equals mx plus b slope-intercept form, well, we already know the slope is negative 2. But to find the b, the y-intercept, we need to take 1 point. Let's take negative 3, 5, because they give it to us. That is an xy value that is on the line. I'm going to substitute negative 3 for x, 5 for y. The reason I can do this is they tell me this point is on the line, so it must make the equation true, and now I can solve for b. So we get 5 equals, this would be positive 6 plus b. I'm going to subtract 6, and we end up with negative 1 is equal to b. So the last thing I always do is I write the final equation, y equals m times x, and then the b value is minus 1. This would be the parallel line. Same slope, it's just the y-intercept will be different. Okay, so this is how you can write the line. There's actually an easier way to do this though. There is a different way of writing a line called point slope, which is y minus y sub 1 equals m times x minus x sub 1. This is great if you know the slope and you know a point to start from. In this case, we know the slope was negative 2, and we know the point is negative 3, 5. Negative 3, 5 would be my x1 and my y1. That's how I would look at it. And so I can just do y minus y sub 1, which was 5, equals slope m times x minus x sub 1, which was negative 3. I can simplify and say y minus 5 equals negative 2 times x plus 3. And that's actually a good answer. You could leave it that way. Now, you may be thinking, is that the same thing as this? Well, if we were to work it out by distributing, we would get negative 2x minus 6, we would add 5, and we would get y equals negative 2x minus 1. So it's the same equation, but it might be easier to write it in point-slope form, where this is called slope-intercept. So either way is good. Let's do 13. Write an equation for a line that goes through 2, 2, that's perpendicular to the line through negative 3, 9, and 4, negative 5. Okay, they don't give us the slope this time. However, let's do the formula for slope. M equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. This would be negative 14 divided by 7, which is negative 2. Now that's the slope of the original line. We want a perpendicular line. So that would be, if I flip this, it will become positive 1/2. The opposite of a negative becomes a positive. The reciprocal is 1/2. So we want the line that's perpendicular to this one, and then it goes through 2, 2. So 2, 2 is the point we're going to go through. Again, it might be easier to use point slope. We have the point, we have the slope, so I'm going to just say y minus y1 equals m times parentheses x minus x1, actually, which in this case, that's 0. Y minus 2 is that's x minus 2, x minus 2. The y and the x just stay as y and x. That right there is actually a good answer. So y minus 2 equals m times x minus x sub 1. That's where that is. If you'd rather do y equals mx plus b, we have y equals 1/2 x plus b. We can substitute 2, 2. I know I'm doing this kind of fast here. And we get the y-intercept is positive 1. So the equation is 1/2 x plus 1. Y equals 1/2 x plus 1. But again, this is just faster. All right, the last problem here, write the equation of the perpendicular bisector of segment CD for point C, -3, 5, and point D, 5, -1. There's C and there's D. Let me connect this. So we have a segment here. We want the equation of the perpendicular bisector. So there's actually two things we need to know here. Bisect means midpoint. So we need to find the midpoint of this segment. x1, y1, x2, y2. Now remember the midpoint, I'm going to say midpoint and then CD. Midpoint is where you add the x's. I'll write the formula over 2, comma, you add the y's and divide by 2. So we would get, add the x values, -3 plus 5 over 2, and then the y values are 5 plus -1 over 2, and what we get is 2 over 2 and 4 over 2, which reduces to 1, 2. Now that's the midpoint. Ooh, actually I drew this really well because it goes right through 1, 2. So there's the point that we're going to go through. Now we want the perpendicular line. Well, if we know the slope of CD, then we can find the slope of the perpendicular bisector. So I can either do the formula for slope or I can just count. Let me count. So I'm going to go down 1, 2, 3, 4, 5, 6. And I'm going to run 1, 2, 3, 4, 5, 6, 7, 8. So the slope is -6 over 8, which reduces to -3/4. That means the perpendicular slope is the opposite reciprocal, which is 4 over 3. 1, 2, 3, 4, 1, 2, 3. From here, because we're going to go through that point, now I can draw it. Okay, that looks good. But I also want the equation. They say write the equation. Here's the slope. We know we're going through 1, 2. So let's do point slope. Y minus, here's x1, y1. Y minus y1 equals m times x minus x1. That's a good answer. But if you prefer to go old school, we can do y equals 4/3 x plus b. We'll use 2, 2. 1, 2. 1, 2. So 2 equals 4/3 times x plus b. 2 equals 4/3 plus b. Subtract that fraction, and we get 2/3. And so it's y equals 4/3 x plus 2/3. And again, just to show you, if we kept going with this, if we distribute 4/3 x minus 4/3, and if you add 2 to this, you get the exact same thing. And that is the end of the notes, but one final joke. Why does a pharaoh talk to, or who does a pharaoh talk to when he's sad? His mummy, of course.